Thank you. So good afternoon. I think it was quite a long day, so we'll try to make it short. And it's a big challenge to keep it within the 10 minutes. But I'm Geoff, working for Aisin. Aisin is a big automotive tier 1 supplier. It's actually the 5th largest automotive supplier in the world. And I'm the manager of the RoadTrace product line. RoadTrace is delivering services to local authorities based on connected vehicle data. And we are helping road operators in their decision-making. So the challenge within these 10 minutes is to show you all how this connected vehicle insight can help road operators. But first, I'd like to start with a little bit of background on the connected vehicles. So what do we mean by connected vehicles? So very often I hear about CAV, connected in autonomous vehicles. And actually connected vehicles and autonomous vehicles are completely different things.
Right.
So connected vehicles are not only the very modern luxury cars. Any vehicle that's able to receive and transmit data is a connected vehicle. So a Formula 1 vehicle, a Formula 1 race car is a connected vehicle. E-scooters are connected vehicles. But it means also that all the delivery van, taxi, shared vehicles are connected vehicles. That's millions of vehicles on the road nowadays. And most of the new vehicles since 2015 are connected, are transmitting data, at least the position. But also from 2018, all the new cars have to be connected. That's mandatory per EU regulation. So now, from these connected vehicles, what kind of data can we get? What are we collecting? The most common and very often referred to as FCD, so floating car data, is the position of the vehicle, GPS position of the vehicle. If you know the position of a vehicle at a certain time, you know its next position 5-10 seconds later, you can then estimate the average speed of the vehicle between the 2 points, for example. And that's how you create real traffic or live traffic information. That's the base application of connected vehicles. But there are many other sensors in the vehicle that we can also use to collect much more useful information. You have steering sensors, you have braking sensors, you have accelerometers in the vehicles, and that's also not something new. That's not only, say, the very modern and brand new luxury cars. Actually, the accelerometers are in all the vehicles since we invented the airbags, because you need accelerometers to control the airbags. You need accelerometers to control the braking of the vehicle, ABS, traction control, and so on. So almost all the vehicles on the roads are equipped with accelerometers. And these are very useful sensors because they are very high frequency sensors that you can use to detect all the movement of the cars. So also analyze drivers' behavior. And from that, you can then detect unusual driving behavior, like harsh braking events. That's a very interesting one, and I'll show you why. So it's been demonstrated in the literature, and I put a few references here, that there is a strong correlation between clusters of harsh braking events, so accumulation of these events at a certain position, and KSI, so real collisions. So I won't go through all these references, but you can find that in the literature. So we can predict somehow where collisions are likely to happen based on the analysis of harsh braking events. But then, is it better to use harsh braking events or historical KSI data? What's the benefit of using harsh braking events instead of KSI? Is it telling exactly the same? Do you get the same information from historical crash data or a KSI or hours braking? Well, actually, it's not telling exactly the same. It's much more useful, much more powerful to look at hours braking events, and that's what we've demonstrated. What we've done is collecting data from these connected vehicles for 3 months, analyzing drivers' behavior to detect these harsh braking events. And then we processed that to identify the location where the probability of a crash was the highest. So clusters of harsh braking events that are showing there is a high probability of a collision. Then we've converted that to what actually happened in the following 9 months.
Right.
So 3 months of collecting data, we predict where accidents or crashes will occur, and then we check that against real collision data, the Stats 19 report.
So they predict it well.
The conclusion was, in the different regions we've analyzed in the UK, so we took some urban area, more rural area, bigger and smaller regions.
Wow.
So on average, 20% of this location of harsh braking clusters that we identified turned into real collisions in the following nine months. What if we had used KSI data, so historical collision data, to predict those future crashes? In that case, the conversion rate, so the amount of future crashes that we would have predicted would have been 6%. So using harsh braking events resulted in more than 20% prediction of future crashes, whereas KSI, historical KSI, is only around 6%. So it's 3 to 4 times more efficient to use clusters of harsh braking events to predict future crashes, which means also that you can prevent those crashes. Don't have to wait and collect real collision reports before identifying those hotspots on your network. And in parallel to that, you have some other benefits. First, the harsh braking events, that's much bigger data sample. So that's millions of events that we collect every month in the UK, just in the UK. So we can look at the freshest data, really actual status of the network now or in the last few weeks or few months. So it's really fresh data. Means it's much more relevant because it's not influenced by changes in the policies, in the speed limits, in the layout of the road and so on. If you look at historical KSI data from 3 years ago, it might be that junction has changed, the speed limit has changed and so on. So these data are not relevant anymore. Also, we can have a real statistical approach. So compared to KSI, where you see a junction, you had 2 killed drivers in the past year. In the next year, if you only have 1, you cannot conclude that the risk level is reduced by 50%, or you don't have a problem anymore. With the harsh braking events, we are analyzing hundreds or thousands of events at each location, at each hotspot that we've identified. So you can really have this statistical approach. And it's a much more precise and accurate data as well. So we know exactly for each event from which direction the car was coming, what was the entry speed, at which point it started to brake, at which point the vehicle stopped, and so on. In the KSI, in the Stats 19, you will know roughly what was the position of the car at the end, but you don't have all the information, not so accurate positioning, for example. Sometimes you only have the name of the road, but you would never know what was the exact direction of the vehicle and where it started to brake.
That was.
So now that's for the background and the approach. One of the first to use this approach in the UK was Blackpool, and Ian Large from Blackpool is here today, so you can ask him to get some feedback. And I'm very lucky today to have Stephen from Transport Scotland with me. And Stephen can give you a few words also on how Transport Scotland is using this approach.
Hi, thanks, Joe. Just start to introduce myself and Transport Scotland, I guess. So, just for those of you who may not know, Transport Scotland are the National Transport Authority for Scotland, and we are responsible for delivering the Scottish Government's vision for transport, and we operate our road and motorway networks. I sit in the Roads Directorate, and I've got a lead on our interests in connected and autonomous vehicles, and more recently on how we can better connect our Traffic Scotland service. So using our Traffic Scotland service, we help ensure the safety, operational performance and resilience of Scotland's motorway and truck road network. Although this offers significant benefits, the intelligent transport systems that underpin it are constrained by the limitations such as the physical location of physical infrastructure and the maintenance burden associated with the supporting detection and communication. In common then with other roads authorities, we're increasingly looking to improve our service. And my particular focus here is how we can realise the benefits our connected vehicles offer, and in particular how we can use the data to help the Traffic Scotland service contribute to improved road safety. We're pleased to be working with Aisin to understand how the RoadTrace analysis can help us in this area. So working with them, Aisin have undertaken a study of our truck road network. If you look really closely at the map, you'll see that we've excluded the main motorway network within the initial study. We did this in order to focus more closely on the areas that we think will get more meaningful insights and useful learning from, rather than locations that are dictated by volumes of traffic. We also determined that it would be of great interest if we could compare both the most recent winter period with a typical summer equivalent, if there is such a thing. Having been presented with the initial findings, we've recently asked our Traffic Scotland operator, Moby, to undertake some further analysis alongside other safety-related data sets to identify whether they can contribute to our ongoing efforts to reduce incidents by identifying otherwise unknown areas of risk and to target future in-vehicle messaging in higher risk areas not covered by VMS. Once this analysis is complete, we'll be able to share that more widely across our relevant teams, including our road safety team, and we believe that this data will provide valuable additional insight to identify risks in our network and support consideration of road safety engineering measures, as well as informing Traffic Scotland's approach to managing the network. And we look forward to making more progress with Aisin in the coming period. I'll hand back to Joss for the rest.
Thanks a lot, Stephen. So, key takeaways, first conclusion. As I said, this approach of using connected vehicle insights and especially harsh braking clusters to predict accident is much more efficient than looking at historical collision data. But also it allows to identify those locations, those hotspots where you've not seen any crash reports yet. So you can really prevent and be proactive in preventing those crashes. It's much quicker as well. So within only a few weeks, few months of data collection, you can already have a complete overview of your network. And as we only need a few weeks or months of data, it's not influenced by changes to the infrastructure or the weather. So you can also look at differences between winter season and summertime. Look at trends when you have lots of tourism and so on, but also quickly identify changes if you change a policy or speed limits. If you change the layout of a junction within a few weeks, you have objective data to measure the impact, the actual impact on drivers. And finally, as I said, it's much more complete data sets compared to crash and collision data, because you have much more sensors in the vehicle giving you lots of insight into how people approach a junction, what speed, what kind of deceleration, from which direction they were coming. And it's a vast amount of data, so you can have this statistical approach with very accurate data. That's really helpful to identify the root cause also of the collisions. Thanks a lot for your attention. We are happy to take questions now, and we have a stand just at the corner there, so feel free to come and ask any question. And I also have a question for you, but happy to take any question now.